When you think of cool planets, Mars and Saturn usually steal the spotlight. But what about Mercury, the closest planet to the Sun? For years, Mercury was dismissed as a boring, cratered rock, just a hot, forgotten world. But almost everything you think you know about Mercury is wrong. Thanks to NASA's Messenger mission, we now know it's one of the weirdest and most dynamic planets in the solar system. Messenger's discoveries flipped our understanding upside down. Today we'll dive into Mercury's shocking contradictions: ice at the poles, a bizarre magnetic field, a giant molten core, and mysteries that still baffle scientists. Forget the dull gray ball from your textbook. It's time to meet the real Mercury. Before we dive into the wild discoveries that awaited us at Mercury, discoveries that would challenge our understanding of planetary formation and evolution, let's take a moment to appreciate the incredible feat of engineering and determination that made it all possible. Let's talk about the hero of our story, Messenger, a spacecraft designed to brave the harsh conditions near the Sun and unlock the secrets of a world long shrouded in mystery. Getting to Mercury is tough. It's not just about pointing a rocket and firing. The Sun's immense gravity becomes a major obstacle. It makes it incredibly easy to overshoot your target and end up crashing directly into the Sun, a fiery end for any spacecraft. So, Messenger embarked on a complex 7-year journey, a pinball-like trajectory carefully calculated to navigate the solar system's gravitational forces. This involved a series of precisely timed flybys, starting with Earth, using our own planet's gravity to adjust its course. Then 2 flybys of Venus, each one a delicate dance with gravity, further refining its trajectory. And finally, 3 flybys of Mercury itself, a daring maneuver to bleed off speed and prepare for orbital insertion. Each flyby required precise timing and engine burns, all just to slow down enough to be captured by Mercury's gravity. In March 2011, after years of meticulous planning and execution, Messenger achieved the impossible. It became the first spacecraft to successfully enter orbit around Mercury. This marked a monumental achievement, finally giving us a complete, unobstructed view of the planet's surface, a perspective we had only dreamed of before. Packed with a suite of sophisticated cameras, each designed to capture different wavelengths of light, spectrometers to analyze the composition of the surface and atmosphere, and a highly sensitive magnetometer to measure the planet's magnetic field. It was meticulously built to withstand and survive the extreme heat and radiation environment near Mercury. This included a large, specially designed sunshade, acting as a protective shield against the sun's intense energy. The primary mission was initially planned to last just 1 Earth year. But Messenger far exceeded expectations, continuing its groundbreaking work for a remarkable 4 years. During its extended mission, it tirelessly orbited Mercury over 4,000 times, each orbit bringing it closer to unlocking the planet's secrets. And with each orbit, it diligently collected a treasure trove of invaluable data, painting a comprehensive picture of Mercury's geology, composition, and environment. It meticulously mapped the entire surface of Mercury, revealing features hidden from our view for centuries. The high-resolution images captured by Messenger revealed intricate details of the surface, showing us a world far more complex and dynamic than we ever imagined. Messenger didn't just update our existing knowledge of Mercury, it fundamentally revolutionized our understanding of the planet, challenging long-held assumptions and opening up entirely new avenues of research. The groundbreaking mission finally came to an end in April 2015. Running out of fuel, the spacecraft was intentionally crashed into the surface of Mercury. In a final act of exploration, Messenger became a permanent part of the planet it had so diligently revealed, creating a small, new crater on its surface. But its legacy extends far beyond a simple crater. Its legacy lives on in the vast archive of data it collected. Data which scientists around the world are still actively exploring and analyzing today, continuing to unravel the mysteries of Mercury. Thanks to the dedication and ingenuity behind the Messenger mission, Mercury has finally emerged from the shadows, transforming from a planetary footnote into a captivating headline act in the ongoing story of our solar system. Forget what you think you know about Mercury. It isn't just a gray cratered ball, a lifeless rock orbiting close to the Sun as depicted in old textbooks. That simplistic view couldn't be further from the truth. Modern space missions have revealed a far more fascinating and complex world. Messenger's images revealed a world with vast, colorful volcanic plains. These aren't just any plains, they're a testament to a fiery past, painted with hues that tell a story of intense geological activity. The colors represent different minerals and compositions, giving scientists valuable clues about Mercury's history. And dramatic cliffs, towering structures that stretch for hundreds of kilometers across the surface. These aren't gentle slopes, they're imposing features that speak to the immense forces that have shaped this planet over billions of years. Those smooth plains? Look closer. They're ancient lava flows, solidified rivers of molten rock that once surged across the landscape. Imagine the scale of these eruptions, the heat, and the sheer volume of material that reshaped the planet's face. Proof that Mercury was volcanically active, and not just for a brief period, much longer than we thought. The evidence suggests that volcanic activity persisted for billions of years, far longer than initially estimated, challenging our understanding of planetary evolution. The planet's surface is covered in giant scarps, colossal geological formations, mile-high cliffs formed as Mercury's core cooled, a process that had a dramatic effect on the entire planet. As the interior cooled and contracted, the surface buckled and fractured, creating these immense cliffs, and the planet shrank, wrinkling its crust like a dried-up apple. This global contraction is a key factor in understanding Mercury's unique geological features. Mercury has shrunk by over 4 miles in radius, a significant amount for a planet of its size, far more than expected. This level of shrinkage indicates a complex internal structure and a dynamic thermal history. Then there are the hollows. Peculiar features unlike anything else in the solar system. Bright, irregular depressions that look like the surface is being scooped away, leaving behind a pitted and uneven terrain. They're young, possibly forming right now, suggesting that Mercury is still an active world, even today. And we don't fully understand what causes them, adding another layer of mystery to this enigmatic planet. The leading theory, the one that scientists are currently investigating most closely, volatile materials in the crust are vaporizing under the sun's heat, a process called sublimation, leaving these strange features behind, a testament to the ongoing processes shaping Mercury's surface. Mercury's surface is still evolving, constantly being reshaped by various forces, shaped by volcanism, the legacy of ancient eruptions, contraction, the squeezing and wrinkling of the planet's crust, and chemical weathering, the slow but steady breakdown of surface materials. It's a complex, dynamic world, a far cry from the inert, unchanging rock we once imagined. Anything but boring. Mercury is a planet full of surprises, challenging our assumptions and pushing the boundaries of our knowledge about planetary science. Mercury's surface can reach 800 degrees Fahrenheit, but MESSENGER found water ice at its poles. How? Mercury's axis barely tilts, so deep craters at the poles never see sunlight. These cold traps stay below -280 degrees Fahrenheit, colder than Pluto. MESSENGER's instruments detected bright hydrogen-rich regions in these craters, clear evidence of water ice. There could be up to 1 trillion tons of ice at the poles, likely delivered by comets and asteroids over billions of years. Some ice is covered by a dark organic-rich layer, possibly also from comets, which insulates and preserves it. So, Mercury is a planet of extremes, blazing hot on the surface, but with ancient ice and organic material locked in eternal shadow. Mercury's magnetic field. It's a subject that continues to fascinate and puzzle planetary scientists. This seemingly small planet holds secrets that challenge our understanding of how magnetic fields are generated and sustained in celestial bodies. Is one of its strangest features. It presents a unique case study, prompting us to reevaluate established theories and consider new possibilities about planetary formation and evolution. The magnetic field is not just a detail, it's a key to unlocking Mercury's past and present. It's much weaker than Earth's, only about 1% as strong. To put that in perspective, it's like comparing a small refrigerator magnet to the Earth's powerful magnetic shield, but the real surprise is how lopsided it is, a characteristic that sets it apart from other planetary magnetic fields in our solar system. This asymmetry is not just a minor deviation, it's a fundamental aspect of Mercury's magnetic personality. The field is shifted far north of the planet's center, by approximately 20% of Mercury's radius. Imagine taking the Earth's magnetic field and pushing its center hundreds of miles off kilter. That's the scale of the displacement we're talking about. This means the North Pole's field is much stronger than the South, creating a significant imbalance in the magnetic forces surrounding the planet. The magnetic field lines are more concentrated and intense in the northern hemisphere, creating a bizarre, uneven shield against the solar wind. This unevenness has profound consequences for how Mercury interacts with the constant stream of charged particles emanating from the Sun. The weak southern field lets solar particles slam into the surface, unimpeded by a strong magnetic barrier. This direct bombardment has likely shaped the surface composition, and contributed to the planet's unique weathering processes over billions of years, possibly helping create those mysterious hollows, those strange shallow depressions scattered across Mercury's landscape. These hollows are unlike anything seen on other planets, and their formation is a subject of ongoing scientific debate. Why is the field so off-center? We don't know. The precise mechanisms driving this asymmetry remain one of the biggest mysteries surrounding Mercury. Theories suggest the dynamo in Mercury's core is only active near the top, with the lower regions perhaps being stagnant or behaving differently. This could lead to the observed asymmetry in the magnetic field, or that the core and mantle interact in a unique way, perhaps through complex fluid dynamics or electromagnetic interactions. The interplay between these layers could be crucial in generating and shaping Mercury's unusual magnetic field. MESSENGER's data has forced scientists to rethink how planetary magnetic fields work, challenging long-held assumptions and prompting the development of new models. The mission provided a wealth of information that continues to be analyzed and interpreted. Mercury proves that even a tiny planet can challenge our biggest ideas about how worlds are built, reminding us that the universe is full of surprises and that there's always more to learn. Its magnetic field stands as a testament to the complexity and diversity of planetary processes. Mercury is incredibly dense for its size, and MESSENGER revealed why it's almost all core. About 85% of Mercury's radius is a metallic iron core, far more than Earth's. How did this happen? Maybe a giant impact stripped away most of Mercury's rocky mantle, or maybe it formed close to the Sun, where lighter materials were blown away. MESSENGER's gravity data confirmed the core is at least partially liquid, explaining the magnetic field. Mercury is less a rocky planet with a metal core and more a giant ball of metal with a thin rocky shell. Its unique structure upends our theories of planet formation and makes Mercury a true outlier among the rocky worlds. Mercury's surface tells a story of both ancient violence and surprising youth. The Caloris Basin, one of the largest impact craters in the solar system, is nearly 1,000 miles across, a scar from a colossal collision 3.8 billion years ago. On the opposite side of the planet, seismic waves from that impact created the bizarre, weird terrain. But not everything is ancient. MESSENGER found vast volcanic plains that are much younger, with some lava flows only a few hundred million years old. The giant scarps, Mercury's shrinking wrinkles, also cut across young craters, showing the planet is still contracting today. Mercury is both a museum of the early solar system and a laboratory of ongoing geological change. Mercury doesn't have a true atmosphere, but it does have a thin, ever-changing exosphere. A cloud of atoms blasted off the surface by solar wind, micrometeoroids, and sunlight. MESSENGER found this exosphere is made mostly of sodium, magnesium, and calcium, the same elements in Mercury's rocks. The exosphere changes with Mercury's orbit, growing and shrinking as the planet moves closer to or farther from the Sun. MESSENGER even discovered a long tail of sodium atoms streaming away from Mercury like a comet. Studying this exosphere gives us a direct look at Mercury's surface chemistry and shows how airless worlds interact with their star. MESSENGER answered many questions but left us with even bigger mysteries. Why does Mercury's surface have so much sulfur, when it should have been baked away by the Sun? What exactly are the hollows made of, and why do they form where they do? Why is the magnetic field so lopsided, and how does the core really work? How has Mercury stayed geologically active for so long? These puzzles are now the focus of new missions like Bepi Colombo, which will build on MESSENGER's legacy. Mercury's story is just beginning, and the next big discovery could change everything we know about planets. Mercury isn't the simple, sun-scorched rock from your schoolbooks. It's a world of wild contradictions. Ice and fire, shrinking crust, a giant iron heart, and a magnetic field that defies logic. MESSENGER turned Mercury into a frontier of planetary science, forcing us to rethink how planets form and evolve. The data will be studied for decades, and with new missions on the way, the next chapter is just beginning. What do you think is the strangest thing about Mercury? Let us know in the comments. And if you want a summary infographic of Mercury's weirdest features, type Mercury infographic below. Thanks for watching.